My pleasure to introduce somebody I think everybody knows, Clark Chinn. Clark is a professor of learning sciences in the Ed Psych department here. Clark's work, he's been one of the leaders nationally and internationally on epistemic cognition, on argumentation and conceptual change. And so it's my pleasure to introduce Clark.
Thank you, Drew. Today I'm going to be talking about evaluating argumentation quality. We're going to be applying a recent framework we've developed to think about how to analyze arguments, and this is work that has stemmed from the Praxis research project that Ravid and I have been working on for quite a few years. And Leah Hung and Ron Reinhardt have been particularly involved in this piece of the project. Our basic idea is that argumentation is a discourse that's valued in a wide range of student-centered, constructivist learning environments. Oral and written argumentation are receiving a lot of attention now in the next generation science standards, the Common Core, and a variety of other international and national standards. And so researchers who are investigating learning and the design of learning environments really need some viable tools then for evaluating student work and also figuring out what it is that we want to aim our instruction toward. So the analytic problem that I'm going to address today is how to evaluate written and oral argumentation, the kind of product that's going to be produced very commonly in line with current standards. So the outline of my talk is this. So I'm going to elaborate now on the analytic problem, and then I'm going to discuss a little bit what I see as the most prevalent solution, which is the structural analysis of argumentation, often based on Toulmin's argument pattern. There are people in this room who are using the Toulmin argumentation pattern, including our research group. So we're going to look at that. Then we're going to argue that these analyses are limited. We'll propose a complementary approach grounded in what we call the AIR model of epistemic cognition, which I'll explain later. And then, if time allows, we'll give some examples of how we're using this approach to promote and evaluate argumentation in 7th grade life science classes. Now, before I get started on all of this, this is a theoretical talk primarily with as opposed to primarily an empirical talk, but we will be giving quite a few examples from our research project. So I want to start by giving you a little bit of overview of our project so you'll have some idea of where the examples we're talking about are coming from. So we have developed a model-based inquiry program that we call Praxis, promoting reasoning and conceptual change in science. We've developed a one-year life sciences curriculum based on model-based inquiry. On all topics, students construct, evaluate, and revise explanatory models based on evidence. Teachers do not teach them the models, they work out the models based on evidence. We have a variety of activities that they engage in, hands-on experiments. We use a lot of what has been called the adapted primary literature, which involves presenting simplified versions of evidence that they can understand. In written form typically, but we also use a lot of visual supplements like evidence from YouTube. We also include a fair amount of lower quality evidence like anecdotes, single examples, because we want students to get, learn how to evaluate bad arguments that they will see on the web and elsewhere. Throughout all of the activities, students use argumentation in their discussion and their writing, and they also regularly engage in the evaluation of the quality of models, evidence, and arguments. So one of our units is on natural selection, and so in this, one of the lessons within this, students are trying to work out why over a period of about 50 years, mountain sheep's horns in the Rocky Mountains have gotten shorter. And so they have 5 pieces of evidence. You see 3 of them here. And first they can try to build their own model to explain what's happening. Then they see some other models which they are invited to decide whether they are viable or need to be ruled out. Then they consider several alternative models and decide which one fits the best, the evidence the best. One of the things we've really worked on over the years is how to make evidence more engaging for students, because obviously students don't have 50 years to go conduct their own natural selection experiments with mountain sheep. So we do a variety of things. We can provide simulated evidence, simulated experiments, or simulated research studies on computers. We've recently moved away from paper and pencil most of the time to doing a lot of the evidence presentation on netbooks, which students work on in 2s or 3s. So here's an example of a piece of one of the evidence where they see that horned sheep never get, or the sheep's horns never get smaller during their lifetimes, which is a real puzzle to them. How could sheep's horns be getting smaller if no sheep's horns are getting smaller? We also, here's an example of bad evidence. So we have a hunter's blog, hunter who is complaining that the sheep's horns seem to be shorter now than they were when he was hunting. So this is a sheep he photographed in 2011 versus 1986. And although this evidence is actually accurate, we want them to understand that they should ignore it anyway, because it's, it's just a very small case study and they have much better evidence with much bigger samples to look at. So that gives you a picture of the kinds of evidence we use. Here's some examples of students' work. This is the models they come up with on their own after the evidence. This is a pretty impoverished one, of a little bit atypical on the impoverished side. Sheep with short horns don't get hunted. Sheep with large ones do. That's why they evolved. So there's a right track there, but there's a lot missing, right? So this one comes a lot closer. Sheep with big horns are getting killed. You're seeing step by step that they're getting killed before they produce offspring, so they're not having offspring with larger horns, and so they have a lot of the pieces in place. One of the things that's missing from this model, though, is they don't explicitly talk about variation in the initial population, which is an absolutely critical thing to understand about natural selection. So even though this is a pretty good model, there's still things to work on here. And so that's one of the things that this lesson focuses on, is thinking about the evidence more deeply to see if there's some evidence that isn't accounted for by this model. So our data sources that I'll be showing some examples from today, they're middle school, 7th grade. We have 4 implementation cohorts, each lasting 5 to 8 or 9 months. You can see there's 4 implementations that we've had. In each case, we're video recording classrooms during most days of the year, 2 or 3 classes per teacher. And in most of the students in these studies are coming from diverse, underperforming New Jersey classes. So I'll talk a little bit more about the analytic problem now, how to analyze arguments. So this particular example I'm showing you, this is from our 3rd implementation, 7th graders from a diverse, underperforming New Jersey school. It's an argumentative writing task used as one of our post-test measures. And so the task is to understand, try to work out why these 2 boys in the Brown family are getting asthma. And so we introduce asthma to them, explain it a little bit, and there's 2 models. Model A is that they have asthma from cockroach dust. So it turns out that cockroach dust is a major source of asthma. Model B is that it's genetic, so they have it for genetic reasons. And they have 3 pieces of evidence. Those 2 are high quality. Oops, there's an error there. They actually both support Model A, sorry. Both pieces of evidence, 1 and 2, support Model A. And then a 3rd piece of evidence is low quality anecdotal, supports Model B. And so we're trying to get them to think about this. And so their prompt is based on the evidence you've seen. So we explicitly encourage them to grapple with the evidence. Which model is better, and give detailed reasons for your answers. So here's some examples. Can you read that? So this student comments on both evidence 1 and 2. says a little bit about how that supports the model. Here's another one. And then a third one. This one I typed out because the handwriting isn't so easy to read. And this student not only gives us this nice long argument, but also shows us a Punnett square to show how it could all work out. So the analytic problem is, these are pretty diverse arguments. How do we get a handle on which ones are better and why? What respects are they better and why? Now, the most prevalent solution to this analytic problem is, I would say, structural analyses of argumentation, often based on Stephen Toulmin's work. Now, I'm going to just pick on myself because this is one of my own past papers where I use the Toulmin argumentation pattern. And basically, the basic idea is you can have a claim. Lily, this is from language arts project we did. Lily didn't deserve to win. There's what Toulmin calls a datum. Lily took a shortcut. This can be qualified with things like probably or something like that. And then you can have a warrant, like a person who takes a shortcut is cheated and so doesn't deserve to win. And then you can sort of build these little components on each other and get a fairly complex argument. But we're basically looking at whether particular pieces of the argument are there. And so Toulmin's basic frame has these components. And I know some of you know this because you, like us, have used this in your own research. A very, very popular one, which we are actually regularly using in our research now, is developed by Songerman, McNeil, Krejcik, and others, which basically looks at three main components: whether there's a claim, what the evidence is, and how the reasoning that connects the claim to the evidence. You can also apply structural approaches to dialogic arguments. So you can say, you can analyze a transcript of an oral interaction using categories like claims, data, reasons, new arguments, counter arguments, integrative arguments, or using Deanna Kuhn's work, categories like clarifying, counter-arguing, rebutting, adding, or disagreeing. So I think the assumption is that better arguments have more of these components or moves, and that they also suggest what you should aim instruction toward. And we buy this because we work on instruction aimed at promoting argumentation that has these characteristics. So it seems to us that structural analyses of arguments are definitely a good thing because they help us distinguish some bad arguments from some good arguments. And here's an example from this kinds of essays you just saw. So we have this student saying, I think model A is correct because in evidence 1 it said, at the end of 8 hours, scientists found cockroach dust in all 20 people's lungs. So we have a claim, we have some evidence. It gives us a tool for understanding what's there and what's not there. The next one also has a claim. It also has evidence. But it also has some argument that explains how it is that the evidence supports the model. So if it's the case that cockroach dust in the airways, it could cause them to start coughing and wheezing after a while. And that's material that wasn't actually in the evidence. They're inferring it to link to the models. So this is a useful framework to help us understand some ways in which student 2's argument surpasses that of student 1. But we want to argue that structural analyses of arguments fail to distinguish some other bad arguments from good arguments. And here's an example. So we've made this argument up, but it's not hard to find these exact lines of arguments on a multitude of websites. Now, okay, so let's analyze this structure. Well, first of all, there's a claim. So that box is checked. We have evidence and pretty elaborated reasoning about that piece of evidence. So we have a description of what the evidence is and a very clear argument for why that supports the creationist model. We also have consideration of counterarguments. Making a counterargument about an evolutionary scientist's attempt to rebut this. So from a structural point of view, this is a fantastic argument. It's going to get absolutely top marks. And so the question is, do we want to leave our argument analysis at the point where we can't distinguish between the worst kind of sophistry you find on the internet versus a really good scientifically or mathematically grounded argument? So if we look beyond structural categories, we look at the various proposals for how to evaluate the quality of arguments, and this is sort of a very quick overview of a few approaches. We have ideas like looking at the acceptability of the reason, the relevance or support the reason provides for the claim, the extent to which counterarguments are taken into account. Clark and Sampson suggests actually quite usefully, you should analyze, you should have a category for whether the argument is correct or not. Others, you can see their accuracy of evidence, strength of evidence, appropriateness of the reason. Pablo and Keith and their group and others they've worked with have used warrants based on different kinds of grounds, such as intuitions, inductions, or logical deductions. And that actually seems to us to be on a very good track, which I'll get to in a little bit. So problems with many of these remedies is that some are just still structural. Whether you have a counter argument, well, we just saw the creationist argument had a great consideration of a counter argument. So that's still a structural characteristic. Some seem circular. It can be really useful to look at for teachers to look at the correctness of the position along with everything else, but it doesn't actually explain why the argument is good. Relevance of the reason also seems circular to us. Others are rather vague. They don't get us very far analytically or instructionally, such as accuracy and strength of evidence. Those sound like great things to talk about. What do they mean? And as we said, we have the more promising one, which is connected to our solution, looks at different kinds of warrants based on the kinds of reasoning that are involved. So to this point, we've discussed some ways of looking at argumentation, why we think these are limited. And so now I'm going to take some time to explain our alternative approach. And I'll start by discussing our theoretical framework, which we call the AIR model of epistemic cognition. And then I'll show how it can be applied to the creationist example and some other examples of bad arguments. So we have a model of epistemic cognition that we're conceptualizing epistemic cognition as having three components: the aims and values that a person has, their epistemic ideals, and their knowledge of reliable epistemic processes for producing knowledge, and so on. Now, applying this to argumentation, we're going to really focus on these two, so I'm going to elaborate and unpack those two components. And our notion is we'll take those two components and we will use that as a lens to identify and evaluate the quality of argumentation. So here's what we mean by epistemic ideals. And so this is Stephen Toulmin again. So we're going to use Toulmin's tools to complement another of Toulmin's tools. Toulmin had the notion of explanatory ideals, which are the standards or criteria that an explanation should aspire to, that scientists want explanations to aspire to. So if we take that idea a little bit more generally, we have epistemic ideals as standards used to evaluate, for example, knowledge claims, and you can have ideals for all kinds of explanatory products. So, or all kinds of epistemic products. So one epistemic product is a model in science. So you can have epistemic ideals for good models. They fit all the evidence, they give an explanation, they're clearly presented, they show each step in the process. And these, by the way, are criteria that our 7th graders come up with on their own. You can have epistemic ideals for evaluating scientific methods, such as sample size, proper comparisons, and so on. And an important aspect of this is you have to have, criteria under which these conditions apply. So we might say that a criteria for evaluating good arguments is that they acknowledge alternative points of view. That's one of our structural criteria. But there are conditions, right? Those alternative points of view need to be sufficiently viable. We don't expect every paper published in an evolutionary journal to have a section where they explain why creationism can't explain these data. So there are conditions under which these are not global, all everything criteria. They have conditions on them. Now, the component of reliable epistemic processes. This is building on ideas developed by our Rutgers colleague, Alvin Goldman, in the philosophy department. The idea here is that there exist in the world causal processes for producing knowledge or other epistemic things we care about, evidence, arguments, and so on. So I'm going to focus on some of the epistemic processes for producing knowledge or models or things of that sort. So one is that, generally speaking, visual observation is a reliable process for telling us things about the world. But, of course, there's conditions on that. The stimuli are not vague or degraded, if the distances aren't too great, if the lighting is good, if we're observing familiar and not unfamiliar faces, in the case of eyewitness observation, if stress is not very high, if very strong theoretical biases are not operative, and so on. So we have some expert knowledge of observation as a reliable epistemic process, and we also know a great deal about the conditions. And this is an interesting one because we also know that many people have a mistaken conception about these processes. It's a problem in jury trials that many people sitting on jury trials and listening to eyewitness testimony are not aware of these conditions on epistemic, on the reliability of observation. So our grasp of these schemas, which I'll call them, can be used in two different ways. So one, we can use it to guide our own active, productive activities to gather knowledge. So if we are doing scientific observations, we'll want to make sure it's in adequate light, that we have taken measures to guard against theoretical biases. We'll use a microscope to observe small things, and so on. We can also use this evaluatively, to evaluate somebody else's claims. So if we hear eyewitness testimony and we have a really good understanding of when observation is reliable and when it's not, we will know whether to discount that eyewitness's testimony. Here's another example. Here's an interpersonal process. So argumentation as a social process, we would say, tends to produce true beliefs. But again, there's conditions. Argumentation works better if there's cognitive diversity in the group, but also perhaps if the cognitive diversity is not so extreme that you can't get off the ground. You need to have uptake of minority ideas. You need to have moves such as asking for clarification, soliciting other viewpoints, and so on. And so, sophisticated knowledge of when argumentation works and when it doesn't is, we think, a part of a person's epistemic repertoire. And again, this can have a productive use, such as if you are formulating a group to make decisions or to reach conclusions, you ought to organize it in a way that meets those conditions. And well, you can use it evaluatively. If you read about a scientific commission report and then you learn that they didn't invite any dissenters, or if they did, they didn't let them talk, it would likely lead you to discount the product of that report. Here's a media process, a kind of a social or institutional process. So you might have different people may have different ideas about when news stories are sourced in a way that are reliable. So one rule you might use is that you want to have editor verified corroboration of two sources. So the editor knows who the sources are and that they corroborate each other. And you could use these productively if you're a journalist. So that's how you organize your newspaper. Or you could decide as a reader, I don't trust stories that have anonymous sources, and so on. We also have knowledge of unreliable processes, or hopefully we do. So an example is in contemporary US media, at least. News shows like to create a debate. Even if almost all the experts agree on one side, they will find the one expert that is on the other side and create an illusion that there's a great deal of debate on this issue. So if you understand that this is a media process and it's really an unreliable process as a guide to expert consensus, then you can use that knowledge of an unreliable process to discount things you see in the media. So that gives you a sense, I mean, just a little flavor for some of the reliable processes, the kind of things we're looking at. If you want to, one of the ideas is that there are a lot of reliable processes that people use in various fields to create knowledge, and I'm not going to look at these in depth, but just some very preliminary incomplete thinking we've done. Looks at some different categories. If you just look at group processes, you can easily come up with a lot of different things that groups can do as part of knowledge producing. Same thing with lots of individual processes, group processes, and again, a lot of these processes are going to be very, very tied to domains. So there's some evidence from psychology of science that it's really productive to take anomalies seriously if you're working in a lab. But how that gets played out is going to be very different in a microbiology lab or in a lab of ecologists, and certainly would be really different from how historians approach this, because the particular domain knowledge you need to examine anomalies and to understand them is going to be really quite different from domain to domain. Okay, so I have elaborated on a framework for epistemic cognition, and so now I'm going to show how we can apply this framework to get some better grip, we hope, on the quality of arguments. So we're going to evaluate arguments in terms of epistemic ideals or criteria and the use of reliable processes. So let's look at the creationist example. So we have, here's one of the arguments in the creationist argument. Creationism is also supported by the Holy Bible, the infallible Word of God. Genesis clearly states that God created the species, including humans. So it seems to us that the writer's epistemic criterion is fitting the Bible, and this contrasts with the scientific criterion that fits the empirical evidence. So this is kind of an obvious one, but it's also core to what's going on. Here's another example. The author of The Fossils Support Creationism carefully reviewed all the fossil evidence and found that there are many, many gaps in the fossil evidence where there are big jumps between similar fossils. Now, the student's criterion here seems to be that I picked one kind of evidence, fossil evidence, and I'm making a claim that that's enough. I don't really need to do any more. But of course, evolution is a bad case for that, because one of the explanatory strengths of evolutionary theory is it explains a very, very large, diverse array of different lines of evidence, not just the fossil evidence, but lots of other evidence. And there's no attention to that. So we can say there's a very different understanding of what the appropriate criterion ought to be to evaluate scientific arguments. So here's an example from one of our other units. This is a 7th grader's essay on whether they're evaluating evidence bearing on 2 models of whether humans are resistant to HIV. And one is quite simply they are, and the other is they're not. And they've been looking at evidence. And this student says that genetic resistance does not exist because of evidence 2. Evidence 2 says, I've never met anybody who's resistant to HIV. That's how evidence 2 supports model 1. And it says that we've had some patients that, though they were resistant because they injected drugs for a long time, didn't get it, but within a few years, they eventually did get it. Okay. Now I'm going to come back to this in a moment when we talk about reliable processes, but we can look at a criterion here. The student had 4 pieces of evidence to work with and is only talking about 1. So there seems to be a difference in epistemic criteria being used here. In this case, it's enough to just talk about 1 out of 4 pieces of evidence and not all the evidence. So here's we've also made this up but it's a compact summary of the kinds of anti-vaccination arguments, again, you can easily find online. So here's an argument. Doctors say that my children will be safer if given a vaccination. They do not have personal knowledge of my children. I do, and I know in my heart that they are better off not taking that terrible risk. So the writer here is using criteria such as feeling in my heart or knowledge of the uniqueness of each individual, whereas the scientific criteria are demand a different kind of evidence. So, given some examples of how you could use criteria to get some purchase on how to evaluate arguments in ways that go beyond structure. So the program of analysis and research here would be the following. You identify criteria that you can defend as valuable, and I'll get to the defend part in a minute. Here are some criteria that scientists have suggested can and should be used for evaluating scientific theories, so fit with as much evidence as possible, coherence with other theories, presence of a mechanism, and so on. You can identify other criteria that students use that may be different from these criteria. You can use those criteria, the expert criteria, as it were, to evaluate students' work, but also look at transitions from the criteria they have to the criteria to different criteria that evolve over time. And as I mentioned, we've actually found that from a very early stage, students bring a lot of positive resources with them. They can, on their own, without much instruction, come up with a lot of very good criteria for evaluating scientific models. So they start with a lot, and so you can build on that quite readily. Now, one of the obviously important issues is how do you decide which criteria you're going to use? And so we think that this means that the field has to get involved in open and deliberate debates about what the criteria are for good arguments. And we would say that it doesn't there's a reason to think that a lot of this criteria used in science are good based on the track record of science and extensive philosophical arguments to support them. But on the other hand, there's lots of evidence, for example, that perhaps it's the case that some of the criteria used in certain areas of science, areas that have been contaminated by gender bias, areas such as the logging industry, which are where the science may be heavily influenced by the industry, that other criteria by other groups outside of science may actually be better, and we should have very explicit debates and thinking about those criteria. Okay, so now we'll turn to the use of reliable epistemic processes to evaluate arguments. So here's that argument we looked at before from the creationist argument. And there's another thing we can notice about this argument. As we all know, when you get a meta-analysis to review, or anybody who's claiming to do an exhaustive analysis, you immediately look to see what procedures they use to exhaustively identify the literature they claim to have done. And this writer seems to have no clue that that might be an important thing here. And indeed, if you're really evaluating all the fossil evidence, my suspicion is it's not just a matter of searching the published literature. If you're really looking at all the evidence, you better be in museums, looking in the back rooms and opening all the drawers. So there are procedures you need to use to exhaustively examine evidence, and this writer appears not to be considering that that could even be an issue. So that would be a negative of this argument. From our HIV argument before, so the argument that I have never met anyone who's resistant to HIV, well, there are ways in the world you can find out about whether something does exist, and those ways don't really include going to the places where they do exist and only looking there. And so this is a case where the evidence is really they're looking only at an AIDS clinic where you get people there who have AIDS, and that is not the first place you would look to find people who are HIV resistant. And here we have a student who gets this. So this is a student essay who writes, the small part of evidence too that relates to HIV resistance specifically or the lab's assistant's interview does state that he has never met anyone genetically resistant. However, one that was genetically resistant to HIV would need to get treated for HIV at a clinic. So this student has completely worked out that this is an unreliable process for addressing the question at hand. And so I think we can see that this is a very specific and important feature of reasoning that this student gets. Okay, so here's one from the vaccination example. Scientists say that their studies show that vaccinations do not cause autism, that these studies were conducted by scientists who believe that vaccinations are not harmful, so they are biased. So again, this is an interesting case, I think, because one of the things we know from empirical studies of scientists always have biases. And science works to the extent that it does work because they actually institute a lot of procedures to try to mitigate those biases, such as double-blind, randomly controlled trials, and so on. So there's a variety of ways in which you can mitigate the biases, and in order to judge any piece of scientific work, you actually have to look and see whether those biases whether those procedures were properly used. And so this would be a case, we would argue, in which the writer seems to not have an awareness of a really important set of processes for achieving reliable scientific knowledge. And so that gives us some insights into something that is missing or lacking in this argument. Now lots of television programs are shedding light on this issue, which there are more and more experts who are coming around and opposing vaccinations and debating the scientific establishment. So again, this comes back to the unreliable media processes we talked about earlier, about just ginning up debate. If you understand that that's a media process, you will understand you can't draw inferences about expert distribution of opinion from that. And here's one about air quality. You know how many teachers teach that .gov websites are reliable and trustworthy. And so this looks, they've got a good criterion, right, for evaluating information on the web. But it would be useful to know that during the Bush administration, the energy industry practically wrote a lot of those .gov websites on this particular topic, or that those who were with very, very close ties to that industry were writing these websites. And so it's not enough to just have sort of a rule of thumb. You actually have to understand the processes by which those websites were produced, which sometimes involves some pretty detailed, even in this case, political knowledge. Okay, so the research and analysis program that is now suggested is developing a large repertoire of reliable epistemic processes and knowledge of the conditions under which they are and are not reliable. There's a few that might be valuable to get started with. We note that the investigative processes, these reliable processes, are often closely tied to the causal processes of the domain you're investigating. What you do to do an experiment in ecology, there's a lot of specific differences from what you do to do a good experiment in microbiology. So that very specific domain knowledge comes into play. There are many relevant processes. We're not going to find 4 and solve all of our epistemic and argumentation problems in the world. We suggest focusing on some processes with an intermediate level of generality, with modest transferability, knowing that you also have to apply domain knowledge, even to apply those from domain to domain. Learning these will, we think, actually be a really important part. So the NGSS, the Next Generation Science Standards, have really unpacked the content. And so we're proposing, I think, what amounts to unpacking the practices as well, and looking at more detail at the kinds of practices that scientists use in various domains to produce knowledge. And there's going to be overlap, but there's a lot of interesting variation as well. So again, here we think that, so how do we decide what processes are reliable? We're again proposing that we should take this head on and be willing to discuss it and have debates about it. Now, with reliable processes, I think we often have empirical evidence to bring to bear. So with eyewitness testimony, it's not just a matter of armchair philosophizing. We now have an enormous body of evidence on the limits and affordances of eyewitness testimony, when we can trust it and when we can't. And so we can draw on those kinds of empirical evidence. You know, we have placebo studies that tell us for the need for double-blind experiments in science. Okay, so I have now discussed our proposed solution, or an alternative approach that can tell us more about argumentation. So now I'll spend the last piece of the talk discussing some examples of how we're using this approach to analyze and promote argumentation with our Praxis project with middle school life science students. So we have really focused quite explicitly on ideals, really from the very first year of our project. So our students come up with, initially individually or working in pairs, they come up with their own ideas about what a good model is, a good scientific model. And then as a class, they discuss them. And we actually know now from a study that Will Pluta has been working on that teachers actually don't do a lot of shaping of these. Teachers pretty much collect the students' ideas. So these are pretty much a transference of the students' ideas right to class norms. But the idea is then that these students are now accountable to these norms, not because the teacher told them so, but because they have agreed that they are going to use these norms in their scientific practices in the classroom. And so these are posted on the board. As you can see, this is period 5. Every period has their own, and they're a little bit different. And they get revised over the year as students get a deeper understanding. So at the beginning, you see a lot of aspects of how understandable it is, and while those don't go away, you get more nuanced understandings of evidence as time goes on. For example, not just supported by evidence, but maybe supported fits all the good evidence. So they start getting more stringent and more carefully worded criteria that better capture what they've been thinking about in their modeling activities. Now, when they write arguments, they can hold each other and themselves accountable to whether their arguments are reflecting. When they say that model A is good, are they using arguments that are drawing on these very criteria that they have agreed will be their class norms? We can also use the criteria to look at arguments. So, here's an example that we looked at earlier. So structurally, it seems to us this is okay, but kind of mediocre. It doesn't explain the evidence in much detail. But we do see some positives here that give some teachers some more insights into what can be built on. So we have seems to, but not quite explicitly, use criteria of fitting a majority of the evidence, because they did talk about 2 out of 3 evidence, but you can see the teacher might want to encourage more explicit consideration of other pieces of evidence and be more explicit about this. And also alludes to jumping ahead to reliable processes, is also alluding to some experimental processes, reliability of the sources. Again, the teacher could see that there's some good initial understanding that could, through class discussions, possibly discuss how those might be elaborated. I'm going to go to this, skip ahead to this one. Here's another one that you haven't seen yet. So this is a pretty sophisticated argument, we think, because it is actually correct that the 2 good pieces of evidence clearly show that allergies are caused by cockroach dust, but doesn't necessarily take it the next step to show that asthma is caused by cockroach dust. And so you can say that this student is using a directness criterion. And this is interesting because it can actually raise questions about, we've had debates within our group about, the viability or acceptability of this criteria and weighing it against what's otherwise some very strong pieces of evidence. And but it gives us some more insights into some of the thinking that the students might engage in. And we actually think this is good thinking, but maybe the student should have had this be outweighed by the strength of the evidence. But these are the kinds of debates now and discussions you can encourage in class to really generate a more sophisticated understanding of epistemic criteria. So now a couple of things we've done about supporting reliable processes of coordinating of one very particular epistemic process. How do you bring all the information together to decide which model is better when you've been given a body of 3 or 4 or 5 or 6 pieces of evidence? And so we've given them a couple of tools to help think about some of these processes. So this is from a mitochondria lesson where students look at 6 pieces of evidence to try to decide whether mitochondria produce energy or movement. And since energy is implicitly, can't come up with the right word, is tightly connected to movement, you can see that distinguishing between those two models is actually pretty challenging. So they have various pieces of evidence and they decide whether the evidence supports, strongly supports, contradicts, strongly contradicts, and so on. So you have these students saying it supports both models. So they consider how each piece of evidence, so this is introducing them to a process where thinking systematically through all the evidence and not neglecting any evidence, and you can see it as sort of the tallying system of review, which is one method of reviewing research. Now in the boxes, they put numbers. So 0, 1, 2, or 3. 0 means this is a really bad piece of evidence, so we should never think about it anymore. And goes up to 3, this is a really important and strong piece of evidence that has to be given very high weight. And so you can see you can get various weightings here. So our idea is that as they discuss what numbers to put, both in groups and as a class, they're going to be prompted to talk about the processes that the scientists use, or the non-scientists, as the case may be, to produce the data that they're considering. So there's another example of a student's diagram from another unit. And so let me show you how these kinds of discussions can play out. So this is from a unit, food web unit, and the students are working out a model of a food web in Greenland. They're working with several species, including seals, polar bears, Arctic foxes, and so on. And we've given them several pieces of evidence, and this is a discussion about the first piece of evidence. So again, we're explicitly trying to encourage thinking about the strength of evidence, 0s, 1s, 2s, and 3s, as a way to really get at thinking about the processes by which that evidence was produced. And the first piece of evidence they're looking at is actually a pretty bad piece of evidence. It consists of a radio interview with a hotel owner in Greenland who is reporting on how many sightings, because the hotel keeps a log of guest sightings of animals. And they reported a change in the number of foxes sighted from one year to the other. They also reported one year there were 2 salmon sighted, and the next year none. So what to make of this if you're trying to build a food web? And so Blair takes this at face value. Okay, so there are more Arctic foxes living in the area near the hotel, but there was more the year before and it went down. Okay, so now we can draw some conclusions about what's eating what based on the patterns we're seeing. But Andy says, well, wait, just because somebody saw 2 last year and there are more Arctic fox, so it's not very articulate yet. So structurally, this is not a very good argument, but we see that Andy is starting to get towards something that might be really important. A little bit later, Erica says, that doesn't really tell you anything, though, because it's just guesses. Like walking around, there's not actual people going out trying to find these things, and it might not even be an Arctic fox. They might just think it's an Arctic fox. Brianna, and also maybe the Arctic fox is kind of like hibernated to another part of the forest and they're not near the hotel anymore. Natalie, I was going to say that people could not be like looking for them or mistake them for an Arctic fox, which cannot be an Arctic fox. So we're starting to get ideas. Well, first of all, people may need expertise to evaluate Arctic foxes. The Arctic foxes, you need to know the behavior patterns of the foxes in order to know where to look. It's probably better to actually be systematically looking for them than just casually writing down whether you happen to see them or not. So we're starting to actually get some, I think, some really good understandings of good observation processes and counting, wildlife counting processes in science. And Regina says, again, kind of recapitulating some other ideas, I don't think they will intentionally show themselves to people. So they might be hiding from us. So I think what we see here is that this discourse, which is focused on, is this evidence any good, helps us develop an understanding that helps the students develop an understanding of causal observational processes and the conditions under which they're reliable and whether those conditions are met in this hotel case. And we can see that although they don't get it right away, they start to really do some very sophisticated thinking. Structurally, we would argue that these are all very simple arguments that wouldn't score very well on a Toolman analysis. But if you look at the reliable processes they're grappling at and the conditional knowledge they're developing, it seems really quite sophisticated. And again, as a last point, notice how the observational processes really are tightly interwoven with the Arctic setting. So in order to, it's not just we've got some general rules of observation, we've got to know, we're trying to observe foxes. We've got to know what foxes do and how they behave and where they are. And that plays our content knowledge actually is going to interface pretty tightly with our knowledge of epistemic processes here. Okay, so I'm going to stop there. So here's a summary. We've argued that the AIR model of epistemic cognition provides some resources to evaluate argument quality. We see these not as replacing structural. We will continue to use structural analyses in our work, but we see these as another additional lens to look at argumentation through. And we've provided some illustrations of how you can use these considerations to actually build instruction that helps students build an understanding of the same criteria that they should be applying when they engage in argumentation. So at that, if there are questions or comments, yes, Mary.
I should say I came in a little bit late, so I heard you talking about the impact that you might like to have on the science standards, right? Have you been thinking in terms of language arts or social studies and debate and other?
So we would argue, at least I would argue, we'll see if Ravita agrees. Leia's here too, runs that class. We would argue that this general framework should be applicable, but of course the particular criteria you may use in different fields is going to be different.
You should be able to argue that very well.
Yes. Yes, Marjorie.
In terms of implications for student learning and instructional practices, I think this model has a lot to offer when trying to use this to begin to evaluate what students produce when they are communicating about their evaluating evidence. It seems that there's that learning to have the discussions, so looking at what is being said in the discourses, that sort of is one set, but then looking at what they may write it's different in the sense, I guess, when we look at what students are doing as they express their reasoning and argumentation in mathematics, sometimes what we've seen is that what they are able to communicate verbally, it's another challenge, particularly at elementary and middle school level, to then get that into writing. And so I guess it's good to see that you are sort of have broadened out this framework of the different ways that you could be looking at the way the students are communicating. Because one of the things students need to learn is that ideas that might be in their head as they're doing this reasoning have to get put out in public, so whether they're talking about it or specifically learning how to write about it. So I guess I'm thinking about some of the examples that you had put up, what the students' work, that there might have been some logical leaps, in terms of the writing, that they didn't get it at what they didn't put in writing some of what they might have been thinking, and by saying, making reference to evidence to or this, as they were thinking about this, there may have been more to the idea, and so I guess using this process and the implications for instructional practices to help students learn about that it has to get written down too if you're expressing this in writing, you know, and this is nice to see. I guess another question.
Well, and we have struggled, I think we have all struggled, right, with the writing issue, how to get students to write down even a fraction of what they could write down. We could just get them to do it. We have, you know, I think like many groups struggled with the audience issue. We have tried to create contexts in which students appreciate who the audience is, and that's not the teacher, but the target audience is somebody who doesn't agree with you and that you need to persuade and explain why your view is a viable one. And we've tried to do this by showing them some, you know, some actually quite bad examples that just seem ludicrous, and, you know, supporting some really ludicrous claims. And they see that and they say, well, wait a minute, you got to tell me more about that evidence. That's ridiculous. And to see, okay, that's how people might be reacting to your arguments. So sort of get them to feel the audience a little bit more. So it's something we definitely struggle with. I think our teachers have made, they've also been quite innovative in coming up with ways to improve and work on students' writing. One of the things that some teachers have done with argumentation as well is give students good and bad arguments that vary in quality, and have them also come up with criteria for good arguments, and they will actually come up with some. So whenever possible, we try to get the students to build the criteria that they are going to be evaluated themselves. So they understand that they are only being held accountable to what they agreed was a good norm.
Yeah, so, well, thank you. And so this was all presented in the context of teaching young kids how to do this. But what struck me is that these processes are exactly the kinds of things you develop as a critical reader, consumer of research, and reviewer, right? And it seems to me that these are these processes that they may have some more technical aspects to them at some level, but this is what we do when we act as a reviewer, say, in an article, right? And so sort of, it's a really nice way of formalizing what I don't think you put in that context. So that's one. The other is, and this is a little connected to Mary, I was thinking, so there's a lot of people here that do research outside of an experimental paradigm, quasi-experimental paradigm. And so you know, I think it's important for folks to think about how this stuff actually connects to that work. And while you may not have worked out all those linkages, I do think it has implications.
So what kind of work are you referring to?
I would say you're doing ethnographic research.
Well, I would I presume that ethnographers, when they are reviewing ethnographies, they have something to say about what makes an ethnography better or worse when they're writing their reviews. So I think that the task is to work out what those standards
Rules of
are.
evidence are. Yeah.
Eli?
I mean, we do, so there are examples in which the kids will argue about, for example, if a particular, you know, are cats a good model system for something, right? So they will, Ron has a wonderful example where the kids see this evidence about wild cats and whether they get a similar virus to HIV, and they initially discount it, it's like cats. So what if it's the cat version of it, so it's cats? And then again, they run into another piece of evidence with monkeys. And then they're like, well, maybe the cats wasn't such a bad piece, right? So part of it, you know, model organism, sample size, whether it's controlled or all those are things that you can have a discussion about. So when you're looking at a study about human HIV, you're not going to get a large sample, and you're probably not going to get any controlled experiments either. So part of it is discussing those conditions of, well, when is a large sample really necessary? Because it's not necessary for every single thing. Either is a controlled experiment.
Yeah, but I'm even thinking about, so, you know, you come in and say, well, we're not going to count certain evidence as much because it's what somebody said. Well, in fact, in some research, what they said is really the evidence, right? So, and so it's thinking about in those from that
Right, and I think that, usually when we do we mean it as bad, it's not one of those.
Right, right, right.
But you can have discussions about whether that evidence should be given a higher weighting if it's good. But that's just all up for debate, and it's kind of debates that Clark and I don't think happen in classrooms, even in the classrooms of other people that are promoting inquiry-based, practices-based teaching.
Yeah, so I guess I'm thinking about these sort of conditions and the quality of evidence, and I feel like one thing that's attractive about the structural analyses is that it's bounded, whereas it feels, this seems critically important, but it feels like you don't know where to stop, where you can kind of say this is what the methods were, or this is what the evidence was. You can always sort of like push a little further, and I imagine people push when they have reason to doubt or not. And I'm just wondering how you sort of resolve what the bounds in an argument is, like maybe how students negotiate what the bounds of the argument are, like what counts as sort of in the pool. Maybe they just keep on going.
Well, I think there's a two-part answer to that. Within the bounds of a middle school classroom, the bounds end up being, whether we intend it or not, pretty much constrained by the range of evidence that they have available to them. So that's
that you provide to them.
Yes. But in some cases, I mean, a lot of our topics like mitochondria, we don't have any way of having them go gather original evidence on mitochondria. You can't see them without electron or some much stronger microscope than they have. Even with chloroplasts, they can see that they are there and they're green, but they can't really do anything more than that hands-on. So even if we're providing some simulated experiments, then obviously those are constrained in a way that fully open-ended observational inquiry might not be. So in some of our contexts, would you agree, Ravik? So our contexts do provide some constraints, but I think the bigger question is, if you're reading a New York Times article, what do you need to know to evaluate it properly? And maybe what we need is some sampling of real world, a really decent range of real world arguments that we think that literate citizens need to be able to evaluate and see what range of knowledge producing processes and criteria are invoked.
Okay, well, thank you so much for